I will show you some background of the Sankey diagram that I have for Figma Data, and I'll also show you where the data came from and the idea. So it started with looking at row graphs and looking if I can do something similar to what they do in row graphs, but then in Figma Data. So when you go to the row graphs webpage, it is a tool that you can use to make data visualizations, and it exports a SVG format that you can use in Illustrator or in Figma to then edit. So it's quite nice, and it has a lot of data samples already, so you can go to the energy flows in the UK. In the end, I used the one from 2007 because the 2051 is a pathway that they planned, but it was withdrawn. So I looked at historical information instead of plans that will not happen. But then it's nice that it already has this data, and this is a good example to do a Sankey diagram on. So you can choose your chart, and then the from and the to are the target and the source node, and then the size is the amount of energy. And here you can see how this turns out. And yeah, here you can choose how you want to visualize it. Do you want to center align it, right align, or justify? And you can also choose different types of colorings for this type of visualization, and choose how you want to show the labels or not, and the values. And then you can export this to a SVG file, for example, to then edit further in some tools. So this is where the data came from and the idea. This is also using D3 behind the scenes. So what I basically did is I took the same table, but then from 2007 instead of 2015. And this shows the power that is going from one source to another source. And I put it in a table, and then I can read that table from this Figma Data tool. So this is a little bit of background. So it has the data table name, and opacity is like hard code or made a variable, so I can change that to change the appearance. I think 0.2 looked okay. And then here it's loading the raw data. So data table to object, data table name. So all these functions are sort of functions that I added into Figma Data. So you can now load Figma tables and use that as a way to generate charts. So we can also print the raw data, and then you get an idea of how this looks. So it has from, to, and terawatt hours. And this is one big array of these objects. So if you look at this table, you can see first one is solar to solar PV, and then there was apparently in 2007 no solar energy in the UK. So this is nice. And then you need to map that data to links and nodes. So how to do that is to source and target, as you saw in the source node and target node. They need to be called source and target. So I look at x from and x2 from these objects, so from and to. and then I map them to source and target. So I basically rename them, and value becomes this power. So let's also print that, so we have an idea of how that looks. So links dot data dot links. So here, source, target, value. So it's basically just renaming these. And then nodes is looking at the from and the to values and mapping the value of that. So how does that look? Nodes is basically a long list with ID solar, ID solar PV, ID solid. And sometimes these show up more often. So if on the left side you would see gas multiple times, for example, but we only want to see it in here once, and that's what the set function is doing. So this is basically a way to, if you have a list of elements that is having multiple times the same thing, then you can use set to make sure that these are all unique. And then this last map is just making it have an ID instead of just a value. Then, and this is all needed to make D3 happy. So this is the format D3 needs to generate the Sankey diagram. So that's how it kind of works. Then this data object is passed to Sankey, and the output of that is nodes and links. And here I look at the child that is called Sankey link, and this is the link template, and this is used to update or enter an element. So if we would update or enter, it either updates existing elements. So if it finds an element with this link name, it will return that element, or it will enter a clone of this link template into the frame. So it needs to know the template, or it will take the first child. But in this case, there is links and nodes, so I need to be specific about what I want to be cloned. Then this element is appended to the Figma frame, and I set the position of the element to be at 0 and 0. That is because the vector in D3 is based on rendering it in the absolute position. So we can look at how that vector looks like. Print. So this function, Sankey link horizontal, that takes a link, will return a path, and this path looks a bit like this. And this is basically SVG code for how the curve of the path should look like. So these are these horizontal links that have some smooth curve, and yeah, you can, I think you can set the, let's see. Work with the default X and Y ancestors of the link shape generator. You can choose a different link shape generator if you want to. So let's try that. Look what it does. So know if this works. No, that doesn't work. This will give the smooth curve. Then the stroke is set. So the stroke is set to the color of the link target ID. So it looks at the target of where the line is going to. So in this case, it looks at the call, and then it looks at what color call is. And color is a scale that is updated based on what is requested to it. Then the opacity is added, and the width of the link is then added as the width of the stroke. Then the nodes are added. So here you have again the node template, and basically the same. So it looks for node names that have the node ID, and start with Sankey node. Then it will update or check that. And it sets the node X and Y position to be correct, and then it sets the size, and it sets the text of the value frame. So if we look at the value frame is the one on the left that contains text, and the text frame contains the name over there. So the value frame text is set to be the value, and the text frame text is set to be the node ID. Then this is appended to the Figma frame. Doesn't really matter where this happens, so it could be before or after. The fill is set of the element to be of the node ID, and the text frame fill is also set to be the node ID color. And then it removes all old elements that are irrelevant anymore, and it console logs something, but doesn't really do anything. Yeah, so this is basically it. So we can now play a bit with the parameters and see what it does. So we can also say Sankey right and see that everything is now aligned to the right. So all the elements on the right are sort of the final ones, and then for example if you see nuclear or solar, they start halfway instead of everything starting from the left, which is if you say Sankey justify. It will justify everything, so all the elements will start on the left and go to the right, no matter how much steps they have. So if you look now at nuclear, for example, you can see that nuclear sort of jumps this whole gap and then goes into thermal generation and then into the different branches there. The node width is the width of the nodes, so it speaks for itself, but you can change that to change the visualization. And the padding is the padding between two elements. So if we now measure the padding between these two, it's always 10. So between these two elements, this one is harder to measure, but there is always 10 between two elements. You can change that here to be more or less. So if we change it to 5, you will see that all the elements will become closer. Then this is the width of the actual result. So the absolute bounding box width minus 200. means that the width is shortened by 200, so there's a 200 padding on the right side, and you can change that potentially to be less, but then you will see that things stick out on the right side. Yeah, and the same with the height, so there is some padding on the top, which yeah, helps to make it a bit more yeah, readable. Yeah, so that's basically how the Sankey diagram works. I hope this could help you in the future if you want to do something custom with the Sankey diagram, or if you want to make a custom graphics for this specific diagram, or use a specific color gradient. So if you want to change the scheme category 10, you can change that to any type of scheme that, of course, D3 has. You can also make your own scheme. So this is just an array of 10 colors represented as RGB hexadecimal strings. So you could also make your own here, right? So if you say I want to have, it will be very ugly, but so you can set your own set of colors here. So now we only have 3, so it will be quite ugly. But you can imagine that if you have a nice color range that you want to use here, you can use that, and then it can be custom for your specific brand or company. But yeah, the default ones are better than coding it by hand.